Okay, is it correct right now? JJ?
Yep, it's come up now. Great, thank you.
Okay, okay, thank you. So today we will discuss, a couple of things. Like first, we'll start with discussing what the high availability is all about. Um, then we will talk a bit about the caching layer and how it can help you to achieve higher availability. Then we'll cover some of the high availability solutions that are related to MySQL. We will then discuss the proxy layer and its impact on maintaining the highly available infrastructure. And at the end, we will conclude with discussing a few of the common problems that are related to the high availability. So, for starters, what this high availability is all about? Yes. So the point is it's not enough, to just build a database infrastructure, right? Because it's pointless to have a database which when it's not available to the application because it's down or there's a network problems or something like that. So you have to keep it, the database tier available and reachable by the application. And for that, redundancy is your friend. And we are talking about redundancy both in terms of the number of servers, because obviously more servers you have, the more likely is that at least one of them will stay available, right? But we are also talking about redundancy in terms of the data centers, for example, because again, yes, if you have two data centers, if you're having infrastructure spanning across two or more data centers, it's more likely that you will survive the event that would otherwise, shut down your only one remaining data center. High availability is also about automating as much of the failover process as possible. And this point is somewhat connected with the next one. So you need to know your business requirements regarding high availability to decide on the actual process. It's because when we are talking about the automating failover process, some of you may think it's somewhat scary, and it partially is, because it's just these are the scripts which are checking for some condition. If it happens, they trigger some kind of action. Definitely, the pro side of this is that the scripts will do it quickly. Yes, they will detect, they will run. On the other hand, this is just a script. It doesn't understand, unless you implement some kind of logic, of course, it doesn't understand your actual setup. But on the other hand, there is some manual failover, yes, so which basically looks like that, you're getting paged at 3 a.m. in the morning, because it always happens at 3 a.m. in the morning. So you have to wake up, you have to understand, check the pager, you have to go to the laptop, open it, log into your system, which also takes time because, all those security measures that are, of course, required and needed, but they take time to log into the system, to check the authentication, to get into the VPN and all of that. So it's taking time, and then you have to, the human has to understand the situation, check what is going on. And again, at 3 a.m., I've been there, I've done that. You are not thinking really quickly. So this is basically a trade-off between human touch, which will give you a better assessment of the situation, but on the price of the longer downtime, or to manual, automated failover, which is quicker, but may not always trigger at the exact case. It doesn't have to be necessary to trigger the failover. So it's up to your business requirements, whether you prefer to trade the downtime for some for some unnecessary failovers and actions. And again, what's also important is that higher availability equal to higher costs, which this is something also you have to keep in mind. So you have to find a sweet spot for your requirements and to get the infrastructure highly available enough, but within within your cost limits. Caching layer is basically the main point of caching layer is to reduce the load on the database. It basically works, as a buffer between the application and the database tier. It caches the reads, it can cache the writes. But we are discussing it here because it can also give you some HA features. Because let's say we're talking about caching reads, right? The reads from the cache can be served to the database, to the application, even if the database is not available. Of course, this may be some stale data, so it's up to your application whether it's okay for it to serve some stale data or not. But the truth is that for I think most of the applications, it's just perfectly fine. Because let's say let's say that we are talking about some kind of social media type of application, and in that case, for the user, it really doesn't matter whether if someone commented on his blog post, for example. It doesn't really matter whether this comment will show up immediately after the comment, actually, or like 10 minutes later. Most likely, he won't even notice that. So in this case, the caching layer can, at least to some extent, prevent you from seeing the database is not available. And in general, caching layer is a must-have for any larger applications, because reducing the load of the database. The point here is that scaling databases is expensive. Databases require beefy hardware, fast disks, plenty of memory, large instances, and scaling them is not easy. On the other hand, caching layer is usually pretty easy to scale up, and you don't really require that much infrastructure hardware for them to perform optimally. Read cache. So we are talking here about memcached. We are talking here about Redis, Couchbase. There are many other solutions. Most of them, are somewhat in memory for the performance, and key value types of the database storage. As we said, the database access is expensive and it should be avoided. Yes, so therefore we basically have this cache to handle most of the reads. For that, it's very important to avoid cache misstorm. The problem here is that sometimes from time to time you have to. The data in the cache. The application is looking for some kind of data in the cache, and this data is either not there, or, for example, it could be outdated. It's timed out. It's time for refresh. So it's very important to handle the situation in a way that you won't, force all those tens of thousands of queries per second to the database. So you have to, if your application can serve some outdated data and this data is available in the cache, then you should do it. And in the meantime, refresh. If you can't serve the outdated data for some reason, then basically you have to, you should wait. You should pause the queries, pause the application until the data from the database is refreshed. And what's important is that you refresh the cache by executing the query only once, because then this query will be quick and it won't be affected by tens of thousands of the queries hitting the database tier, which will at least impact the performance, if not kill the database completely. And again, what I said earlier, if you can serve some old results, you can partially hide some issues with the database, which is something you would probably want to look for, and because it just makes better user experience. For write cache, it's somewhat similar. So the point is not to write directly to the database, but to use some kind of persistent queue for that. For example, it could be either Kinesis or for example, RabbitMQ. The point here is that the persistent queue also has to be highly available. That's certain. So you can either use like Kinesis, which is AWS service, and it is highly available by itself. Or if you are using, let's say, RabbitMQ, you would probably need to implement high availability on your own. But whole point of write cache would be to help you to avoid overloading the data tier with writes. So similar case with selects, right? Let's say that for some reason, sometimes your application has to execute multiple tens of thousands of writes, and all those writes, when running at the exact same time, they would probably cause significant impact on the performance of the database. So you can, instead of pushing them into the database, what you can do is push them into the queue. And then you can define a fixed number of workers, like 10, 100, depending on your hardware, depending on your needs. That will basically walk over the queue and work over the writes and apply them to the database. And again, it helps you to minimize the impact of the database not being available, because the application, it can write. Yes, it can. You won't get some errors connecting to the database. You just be able to write. It's just that for sometimes, it's just that those writes won't be, won't enter into the database at the given time. Let's now discuss a little bit of the part of the high availability solutions for MySQL, because there are plenty of them, and we definitely won't cover all of them today. Let's start with DRBD. It's a distributed redundant block device. Basically, this is basically a RAID 1 mirroring over the network. So we are talking about mirroring a block device over the TCP protocol. The point is to maintain an exact copy or two, one for the disaster recovery, of your volume of your block device in a separate location. It could be the same. Usually it's the same data center plus maybe one copy outside for the DR. It's an active-passive model. So one of the block devices is mounted and active. The other one is just accepting changes, applying changes. It is possible to, from what I understand, it is possible to, from what I heard, it's possible to use the DRBD in active-active mode using some kind of clustering file system. I haven't used it. I haven't seen it in production. It might be possible, but you would have to take a look at the performance impact of it. So it's if needed, you can do some research on this part. So in general, DRBD works nice if you have a single database node, because we are talking about one-to-one copy or 1-to-2, yes, one active to passive. So it's hard, really. It's not feasible to use for any kind of larger infrastructure. The problem with DRBD is that this passive-active switch takes some time, because practically it is more or less like you would pull out the plug from the running database server. So the InnoDB recovery is required, and InnoDB recovery may take even tens of minutes, depending on your workload, depending on the amount of writes that you are doing. You can't use the passive node for anything, except if you try to implement this clustering solution that I mentioned earlier. But in general, by default, you can use it for doing some queries or doing some backups or something like that. So it's just a single node, as I mentioned, so it's not feasible for larger scale environments. And in general, it's a really good tool. It's really, it's a proven tool, but its problem with the use cases are somewhat limited.